All right, welcome everybody. Today we're going to see some magic. Before, if we wanted to find the derivative of some, let's say there's some function f of x equals 2x squared plus 5x plus 7, how would we do that, right? What would we do? We'd, find the derivative, right? So f prime of x is equal to the limit as h approaches 0 of some f of x plus h minus f of x over h. And we had to go through that whole process of plugging in x plus h for x here and x here, and going through that process, factoring out the h. That was in the previous video, and we've practiced a few questions like that, right? But maybe there's a little bit of magic and maybe a little bit of a shortcut. So here, what I'd like you to do is try and, on your own, just using this formula, right? Find the derivative of this function, right? And if you find it, let's just say it should have been 4x plus 5, okay? And what I'll do is I'm going to show you some magic that if I wanted to find, let's say, the derivatives of these functions, right? There's a little bit of a mental shortcut you can do. So, like, if I wanted to find the derivative of this f of x, where I have x to the 5 plus x to the 4th and so on, the traditional way, or I'm sorry, the original way of finding the derivative, we would have to use f of x plus h minus f of x over h. Like, imagine having to put in x plus h into all of these and expanding it out. It just feels like it's just way too much. So here, let's see if you can follow the pattern that I'm having here. So let's say if I have some for this function here, for f of x. Wait, let me make sure this is not in the way. Okay, that looks a little bit better. Let me zoom out, fix the resolution. Okay, I think that's much better. Okay, so here, watch the magic. If I were to say this is the original function, how will its derivative look like? Well, let's see. This would be 5x to the 4th plus 4x cubed plus 3x squared plus 2x plus 1. So this is the derivative of f of x. And I was able to do that all without using this this derivative notation right here of doing all this work. I could just use this little trick I'm kind of that we have here. Did you find the pattern? Like, how did I go from x to the 5 and then 5x to the 4th? What was the rhythm from x to the 4th to 4x cubed? Let's try another one. If you think you found the rhythm, try and do it for the next one. But if you want to see another example, let's see. If I have 4x to the 5th, the derivative of 4x to the 5th will be 20x to the 4th plus 9x squared minus 10x plus 7. The idea is you are multiplying the exponent by its coefficient. So 5 times 4 is 20. And then that 5 minus 1 is 4. And then you're just subtracting 1 from the exponent. 3 times 3 is 9. 3 minus 1 is 2. 2 times negative 5 is negative 10. 2 minus 1 is 1, so that's just, there's that invisible 1. And here, notice that this should be 1 times 7 is 7, and 1 minus 1 is 0. So some x to the 0 is equal to 1. So you're just doing 7 times 1, which is here, and that just becomes 7. So if you just have some, where the exponent here is just 1, you just use the coefficient. And for this part, notice we haven't been doing anything to the constant term here. And then you'll find out that the derivative of any constant is 0. And I'll explain that very shortly. What I'd like you to do is try and do these on your own. Like for h of x and q of x. what would be the derivative of these functions here? Pause the video and try and go for it, yeah? Here, 300 x squared plus 400 x minus 7. 10 times 10 is 100 x to the 9 plus 8 times 7 is 56 x to the 7 minus 25 x to the 4th plus 4. And last one, some x to the 100. What would it be? What would the derivative be? It would just be 100 x to the 99. Okay? So this little idea of a trick we call the power rule. So let me get one little sticky note right here. So if I have some f of x equals, some f of x equals x to the n, right? Where n is any whole value, right? Any whole number. I'm sorry. N should be any positive whole number. The derivative, if I said f prime of x, what's the rhythm that you're actually doing? Like if I said, hey, what's the derivative of x to the 100? What you're doing, it's just 100 times x to the 99. So here you're just doing n times x to the, and then what's going to happen to the exponent each time? There's a minus 1, right? So how are you going to show that? How are you going to represent that? As n minus 1. And here we have the power rule. So it's much easier to take the derivative using this nice little technique versus having to use the limit definition over here. Okay, so yeah, this is a very nice key little tool. One quick thing I wanted to show you was here, y is the derivative of a constant function 0. So notice that when we had notice we didn't really touch anything. Like here, the derivative of x was 1, but the derivative of 5 is 0, and the derivative of negative 8 is 0. The derivative of any constant function is 0. So I'll just quickly explain why. Here, if I said, hey, we had this function f of x equals 5, right? So here we're finding y is the derivative of a constant function 0. So if I had f of x equals 5, well, what does the graph of this function look like? If I said, hey, if we have f of x plus 5, if we have f of x equals 5, well, what does this graph look like? It should just look like a horizontal line at 5. So notice that the graph of this function f of x equals 5, it's just a horizontal line like this, okay? So if I said, hey, what's the derivative of this function? First, we need to understand, what does the derivative of a function calculate? Like when you're finding the derivative of a function, what is it helping you calculate? Pause the video and try and recall this from our previous lesson, but it calculates the slope at, it calculates the slope at any given point. But here, what is the slope of any point on this graph? The slope of any horizontal line here, it's just 0. The slope of any point over here is 0. So the derivative of any constant function will always be 0. Okay? Alright, I hope that helped. This was a short little video. I'll see you for the next one.